Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about pyridine. Look at the structure of pyridine. There are 5 carbon and 1 nitrogen. Nitrogen contains lone pair and that is sp2 hybridized orbital. Now look at the unhybridized p orbital. So pyridine has 5 carbon and 1 nitrogen, all are sp2 hybridized. sp2 hybridization is planar. It makes a planar pyridine ring structure. Each ring atoms also contains unhybridized p orbital, and that is perpendicular to the plane of sigma bond in plane of ring. Here p orbitals are parallel to each other, so overlapping between p orbitals is possible. The total number of non-bonding electrons are 6, 5 of 5 carbon and 1 from nitrogen. So the resonance of 6 electron follows the Haeckel rule, so it is aromatic. Now basicity, you can look at this to a structure. Pyridine is more basic than pyrrole. So pyridine contains lone pair of electron. Now you can see the pyrrole contains lone pair of electrons. So why pyridine is more basic than pyrrole? Pyridine is more basic than pyrrole. You can see the pyridine, benzene and pyrrole. Look at the situations. So basic depends on, or basicity depends on availability of lone pair. Pyridine nitrogen have lone pair of electrons in the same plane of pyridine hybridized orbital plane. So it is not participating to resonance phenomenon. Lone pair is readily available for acid-base reactions. In case of pyrrole, nitrogens have lone pair of electrons perpendicular to the plane of pyridine hybridized orbital plane. It participates in resonance delocalization of lone pair, not readily available for acid-base reaction. As lone pair of electrons of pyridine are readily available than pyrrole, pyridine is more basic than pyrrole. Now you can see the pyridine is less basic than aliphatic amines. Aliphatic amine structure, you can see sp3 hybridized, and pyridine sp2 more electronegative. This is the least electronegative. So sp2 hybridized end is more electronegative, more S character than sp3. Lone pair of electrons more closely held towards more electronegative nitrogen, less available for acid-base reaction. As lone pair of electrons is not readily available in pyridine, it is basic than aliphatic amine. It is very important concept. Now tautomerisms. You know, tautomeric structure involved when pyridine substituted at second, fourth position with groups such as XH. So look at 2-hydroxypyridine at 2 positions and 2-pyridone, hydrogen bonded donor and hydrogen bonded acceptor. Now look at the properties of hydrogen bonding. Pyridine is water soluble. Now synthesis. Hence pyridine synthesis. You know the condensation of an aldehyde with 2 moles of beta dicarbonyl compound in ammonia. Look at here, ethyl acetoacetate, you know, and you have read in part 2. The ammonia formaldehyde, you will get this tetrasubstituted pyridine, dihydropyridine, and then oxidations, you will get the aromatic pyridine ring form, and then finally you will get the disubstituted to 6-dimethylpyridine. Now hence pyridine synthesis, their mechanism. First, novel gel condensations between beta ketoester and aldehyde. You can see the unsaturated carbonyl compound and formation of esteramine in the second steps, the formation of enamine. Now you can see the formation of dihydropyridine. First Michael additions, and then tautomerizations, then nucleophilic addition, then dehydration, you will get the tetrasubstituted pyridine. Now Gureshi synthesis, modification of Hans synthesis, use of cyanoacetamide as the nitrogen containing components. You can see the cyanoacetamide in presence of acetone, potassium carbonate, it gives to pyridones, and then 3 alkoxyenones in trials it give these products. So from 1,5-dicarbonyl compounds, ammonia reacts with 1,5-dicarbonyl compounds to give 1,4-dihydropyridine, which are easily dehydrogenated to pyridines. Look at this reaction scheme. From oxazole, this is very important reactions. Synthesis pyridine or synthesizing pyridine derivative by Iltil-Selter cycloaddition between azadiene and dinephil, followed by an extrusion of the resulting breach of the bicyclic intermediate. Now reactions, electrophilic addition to nitrogen, protonation due to basic properties, and N-alkylations. Now reaction, imidazole is approximately 100 times more basic than pyridine. Why? Protonation of imidazoles yield an ion that is stabilized by the electron delocalization. You can see the pyridinium cation, and in the same aqueous acid you will get imidazolium cation. This is the resonance stabilized. So this is the main important concept here. Imidazole is approximately 100 times more basic than pyridine. Now electrophilic substitution to carbon. Pyridine gives electrophilic substitution at 3rd position. Look at the reaction. Resonance situations. N is negative, so positive charge on nitrogen destabilize the structure. Here attack at carbon 2 and carbon 4 generate N plus intermediate, and less favorable. Only C3 is favorable as it can only not generate the N plus intermediate. Now nitration, you see the 3-nitropyridine, sulfonation, you see the 3-sulfonic acid of pyridine, you see the halogenations at the 3 positions, and 3-bromopyridine is produced in good yield by the addition of bromines in oleum, and 3-chloropyridine can be produced by chlorination in the presence of aluminum chloride. Now nucleophilic substitution. Why pyridine undergo nucleophilic substitution reaction at position 2? So attack on 2nd, you can see the first resonating form. 2nd position gives more stable intermediate containing negative charge on nitrogen. So thus 2nd is more favorable. Now Chichi-Bevin reaction, first example, you can see that pyridine 2-amine. You can also look at the mechanisms. Pyridine as nucleophilic catalyst, you can see used as a catalyst for acylating phenol, alcohols and amine using acyl chloride anhydride. You can look at here alcohol, acyl chloride forming ester, and this is the mechanistic steps. Reductions, complete reductions, you can see the pyridine. Now medicinal uses, anti-tubercular agent, isoniazide, you can see the presence of pyridine ring. Antibacterial agent, sulfa-pyridines and sulfa-alazines, you can see the pyridine structure. Anti-cholinesterase agents, pyridostigmine used in the Myasthenia gravis. You can also see the proton pump inhibitors, omeprazole, lansoprazole, pantoprazole, rabeprazole used in peptic ulcer. So you can also see vitamin B3 and vitamin B6 contains this mite. So now my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.